Let us look at a very interesting problem now. Find the number of different 8-letter arrangements that can be made from the letters of the word daughter such that all vowels occur together. So vowels are A, E, I, O, U. I hope you know that. And the main thing is that they should occur together. So the options I give you are 2120, 36, 2880, 720, and 4320. So I'll just give you a hint to solve this problem. Don't get intimidated, just keep on trying and see if you can solve it. So the hint is that consider vowels as one object and see the arrangements. Even if you don't get the right answer, it's fine, because if you just think along these lines, then it will be very good for you. So the answer is actually 4,320. So let us see how we arrive at this answer. Go to the next page. Let's look at the solution now. So you have daughter, and we have to form 8-letter words out of daughter. So daughter has how many objects if we consider each alphabet as a separate object? 8, right? So we have 8 distinct objects also. So all objects are different, all alphabets are different. This is important. And how many vowels do we have? From A, E, I, O, U, you have A, U, and E. So you have 3 vowels, right? So we have A, U, and E. So 3 vowels. And we have to form 8-letter words with vowels together. So that is the objective, 8-letter words with vowels together. Like I said in the hint, try to see what it means to have vowels together. So for example, I can just have 8-letter words because there are 8 distinct objects. So you just have A, U, and E together always, right? So I'll just put A, U, and E together, and the other alphabets like this. But I can move around this piece with A, U, and E together in front or back anyways, right? I can do like A, U, E, D, G, H, T, R. This is also a good arrangement, which will produce a 8-letter word. And I can also go and move it here, right? So all these arrangements are possible. It seems like here you can see that this is treated as one single object here, and it behaves as a single object, and you can just see the arrangements of 6 distinct objects taken 6 at a time, right? You are just doing the arrangements of 6 distinct objects taken 6 at a time. So how many of these are possible? It is 6p6, right? So 6p6 is actually 6 factorial. Please note that actually I should have mentioned it, but it's very good to know that if R is equal to n, like you have npn, so n distinct objects taken n at a time, that is actually same as n factorial. You can check it. It's just n factorial divided by n minus n factorial. So it's the same as n factorial. So this is an important fact. So this will help you to save some time sometimes. So it's just 6p6, which is 6 factorial. So have we covered all the arrangements or all the 8-letter words with vowel together? Is this sufficient? if we find the arrangements of 6 distinct objects? Please think about it. Why did I actually have A in the beginning, U second, and E third? Can't I also have this arrangement with E first, A second, and U third? This is also a 8-letter word with vowels together, right? So there's no reason to actually have A as the first one, and here also I can have E as the first one. So within this one block of vowels together, you still have arrangements. So AUE, EAU, or UAE, these arrangements are also possible, right? So we have to consider both this kind of sequence, which is horizontal, with one as AEU, considering them as one object, and also moving around the objects within these vowels, right? So what I'll do is, you have number of 8-letter words with vowels together is first the arrangement of 6 distinct objects, which is, we already know that it is 6 factorial, but I'm just writing it. Arrangement of 6 objects, leaving out the distinct, and multiplied by arrangement of 3 objects. So these 3 objects are the vowels. So vowels A, E, U. So there are 3 objects. So you can go and do this arrangement, like I said, of 6 objects with A, E, U as single object, and then within these 3 objects you can arrange the 3 objects in different ways. So you have to consider that. So then you apply the fundamental principle of counting here. So you have the event of arrangement of 6 objects multiplied by the arrangement of 3 objects. These are the vowels. And we already know that it is 6p6 multiplied by 3p3. Like I said, you should just remember that it is 6 factorial multiplied by 3 factorial, and the answer is 4320. So basically 2 things you have to remember. One is just that NPN is n factorial. So this is one fact you should remember from this question. Another very important one is that whenever you see this word coming together, so you have 3 objects coming together or 4 objects coming together, that implies that you treat this as a single object and also consider the arrangements within that single object. So you can solve such kind of questions again. So you can also consider like other kinds of questions like 1, 2, 3, 4, 5, and you want 4 and 5 to come together in all 5-digit numbers, then you can consider 4 and 5 first as one object, and you will have 4 objects arranging. So it will be 4 factorial with the arrangement of 4 and 5 as a single object, and within this object you have 2, so that will be basically 2 factorial arrangements within. So this kind of question, basically of digits coming together, alphabets coming together, you should look at a single object and also arrangements within that single object. So this is the takeaway from this question.